Welcome, ladies and gentlemen, to our edition number 6 of K-Talk, our monthly live show with all the exciting topics of the coming trade show K in the German city of Düsseldorf. Long before the exhibitors built up their booth on the show floor in October, the topics and technologies are being prepared. Good to know, so we can discuss about them already now. The title of today's edition is Plastics in Motion, How Polymers Changed the Automotive Industry. As usual in our K-Talks, I invited 3 guests, all of them true experts in this sector. Here we go. Welcome, Dr. Frank Schönberger of Fraunhofer Institute LBF. Good to have you with us, and regards to the German city of Darmstadt.
Thank you very much. Happy to be here.
Next is Dhanendra Nagvanshi, Global Marketing Leader for EV batteries and electricals for the automotive industry at company Sabic in Michigan, USA. But right now you are in Germany joining the battery show in Stuttgart. Welcome, Dhanendra.
Thank you, Guido. Hello, everyone. I'm thrilled to be part of this discussion today.
And number 3 is Ed Richardson, editor of the oldest trade magazine of the world, Automotive Industries, joining us today from South Africa. Good to have you with us, and thanks for joining, Ed.
Good afternoon, yes.
Before we start with our discussion, I'd like to invite you, dear viewers, to participate and send your questions and remarks to us here in the studio, or type them into the chat box right beside the video. I will pass them on to my guest, and we will try to answer them during the show. So don't hesitate. The more you participate, the better we know what you are interested in, okay? Let's start. My first question goes to you, Ed. The automotive industry is in the middle of its most drastic restructuring process of all times. The end of the combustion propulsion system is coming nearer and nearer. Is that good news or bad news for the plastics industry?
Okay, all right. So my brain works with looking at problems and then kind of finding a solution somewhere. I'm sitting in the southern tip of Africa, as you said. So I've got a different perspective. I mean, today I've got 6 hours of load shedding or power failures, rolling blackouts, and much of Africa is the same. I'm sure much of India is the same, and South America. So we're in Europe and America, and Japan at the moment. Tokyo doesn't have electricity. So in Europe, you're all going off about electric vehicles. I drive past Volkswagen in Utrecht, which is now been renamed, but and it's got a huge sign there saying the future's electric. But I don't know where they're going to get the electric cars for Africa. So yes, the future's electric. Sorry, this is my own little hobby also. But then in terms of plastic, getting back to your other question, absolutely it's changing. The automotive industry is changing hugely. It's not since, I mean, the kind of stuff we're writing about, it's since the change of the horse and cart to automotive, to the motor industry. The first automotive industries was the horse and buggy. So the early years, they actually saw the change coming through, and then the absolute, before and after the First World War, the world changed through mobility. Now the industry is changing because it's got new competitors. The industry was quite comfortable in itself because it had a closed ecosystem where you had certain suppliers, and they were locked in, and they kind of supplied and got beaten up, and they beat up in return. But now you've got completely new suppliers. You've got the Tesla, which is just a complete different thinking. You've got Google wanting to do a car, or doing a car. And then you've got plastics now, which are tackling the monopoly of steel. They've really taken that out to a large extent. On a lot of components, and then obviously aluminium they're starting to take out because it's lighter, and the next target is the magnesium wheels and stuff. So it's actually changing it fundamentally. And yeah, the other guys know much more technically than I do, but it's actually very exciting. It's exciting for me as a journalist to write about it. I'm not quite sure what it's like sitting in the industry. If you're not close to retirement, if you're close to retirement, it'll be quite fun. But if you've got 20 years left, going to be quite exciting.
Okay, let's pass the technical question to one of the other participants. Frank, you are in close contact to both OEMs and suppliers, tier 1 suppliers, tier 2 suppliers, and talking on a daily basis about new technologies. Today we have a, let's say, participation of plastics in the car, in a passenger car, of roughly 15%, right, in terms of weight on the car. So there is still a lot of potential to maybe substitute other metal materials and stuff. What do you see the most potential at the moment to bring in more polymers into the car?
So maybe I start with the change in requirements. So obviously the requirements will change when the engine is driven on the electrical way. So meaning you probably need certain properties, different properties that you needed before. So let's talk about safety, reliability. So this is in the context of flame retardancy, for example, in the context of insulation properties, and so other like structural crash behavior and stuff like this. So it will change. And so from this way, so I would actually see there are more opportunities so to increase the plastics share in the car because it has great potential. So plastics are already quite good today, but we can make them better. So so in terms of lightweight, insulation properties, functionalities, so we get autonomous driving, and so all of these fields, I would say, have quite a lot of potential. So, and in my personal opinion, the amount of plastics will increase in the car.
Good news for you, Dhanendra, right? Because you're working for an automotive supplier, SABIC, and if the share of plastics in a car will increase, means good business for you, right?
I think it's an exciting time for anyone who is in the plastic industry or in a value chain to where the plastic is being used in the automotive. You know, engines used to be the heart of a vehicle, and those are going away. And a brand new component, battery, is being added in a car, which is one of the largest, one of the heaviest, and one of the most expensive component today. And traditionally, steel, aluminum, and a little bit of thermosets are being used, but it opens up a tremendous opportunities for plastic. As Frank was talking about the flame retardancy. So if you write plastic with the right properties towards the changing requirement of the industry, if it's brought as a solution, it can open up a new market for plastics. At the same time, I think it brings a tremendous value for car manufacturers and the battery suppliers as well, because you can make a solution more optimized, lighter, safer, better performing, and lower environmental impact. So I think future of plastics with the trend of electrification is super bright.
If you're looking at today's cars, let's say passenger cars, to have a simple example, and looking back into the, let's say, late 70s or 80s, where we had a Volkswagen Golf weighing around 800 kilos. Today, the same model, I would not say the same car, but the same model weighs 3 times more. So even though we have lightweight technologies, we have more magnesium in the car, we have more aluminum in the car, we have more plastics in the car, even though the cars have ever since grown in weight, because we have more features in the car, safety features, technologies like assistance systems, climate control, and that stuff. But in the future, as you said, Dhanendra, there will be even more heavy technologies in the car, like batteries, for example. So Ed, is that a tendency, or is that a trend that plastic suppliers can turn into the better? Or do you think that even though we increase the number of plastics in the cars will even get more heavier?
Well, in fact, I was writing about it earlier this week. It would seem, unless we get an alternative to lithium ion or something like that, the batteries, an equivalent EV car now is heavier than the ICE car, and it's just the way it is. So you're until they can make lighter battery technology, they've got to save on weight wherever they can, and that is where the plastics and the sort of polycarbonates and stuff are coming in nicely. And then what's also coming through on the themes there is recyclability, and what excites me is the bioplastics are coming in as well. So you've got much more sustainable materials in terms of plastics. That's no longer just disposed of. Just gets thrown away. So that's what's making it also more sustainable. What's interesting to me is this whole focus on green. Again, I'm sitting on a continent where we're not kind of worried about that at the moment, but in the Europeans and the consumer-driven and government-driven concern on the circular economy and the greening, that's the opportunity for plastics. And aluminium sees it as an opportunity as well, because a huge percentage of aluminium, I think it's 80 or 90%, is actually recycled. And the power use goes into the initial making of the aluminium, and after that it's not as much, it's not as angry on power, and it's infinitely recyclable. And plastics I know have to get there, or they can be recycled into something else. Those are the exciting movements.
But there are also experts saying that even though we have good opportunities to run the plastics in circles, we still have a big learning curve to do, because if you look, for example, to metal sheet, that means steel material, look into aluminum, look into magnesium, all these technologies have learned for decades to run their materials in circle. So the circular economy in those materials is already working fine. But the plastics industry still has to learn that. So we are at the moment on the next step to learn that and to implement that. Frank, how much time does the plastic industry have to really perform as good as their colleagues from the metal side, for example?
So I wouldn't say the question is not just how the plastic industry would perform. So because this is one aspect. And from my personal opinion, so it's more or less an interaction between the plastic industry, the automotive industry, also the suppliers. And because when we want to include recycling technology, so this is probably not a thing that only one player can do. So this has to do, or this has to appear all over the full chain. So obviously, the OEM or the supplier, the tier one, can use bioplastics, can use virgin polymers, so that are manufactured in a very good energy way. But on the other side, so you need to make sure that the recycling can be done. And if you have an automotive part or automobile, so you need to make sure that so you have a good way to bring up the material in a way that you can recycle it again, for example. So there are several ways. You can disassemble the car, which is not possible, so maybe just for a few parts. You can shredder it, and so then you have different ways how to reuse the plastic. So, and I think this is a quite complex story, and so it has to be worked over the full chain, in my mind.
Dhanendra, I guess that in your company and in your production sites, you already apply those modern technologies to recycle, to reuse the remainings of the production process when producing plastics parts, right? So post-production recycling parts. How can that develop in the coming years, and what efforts are you doing to bring those materials back into the process again?
Absolutely. At Sapic, we are completely committed to circular economy. We have initiative with True Circle, where we look at mechanically recycled material, even to the chemically required recycled material. So, world's first polycarbonate chemically recycled plant which is now operational at Digital Sapic. So we also will look at the renewable feedstocks as well to make plastic. So it's a tremendous interest. Whole industry is looking for more sustainable solutions. So we have been playing our part with respect to bringing these materials to our customers. But recycling is one aspect of sustainability. We even look at the energy consumption, right? Aluminum is an energy intensive process. So what if you make a plastic part, about 10 to 15% reduction in the CO2 can be achieved just the way the plastic part is produced versus how an aluminum part is produced. So lower CO2 emissions, lower energy demand, this all contribute to the sustainability.
Ed, we all know that the automotive industry is among the most demanding industries when it comes to cost and price pressure. And we know that the OEMs over the last decades learned quite well to press the very last drop out of their suppliers. So there is no doubt and no question that in the near future, the OEMs will ask their suppliers to make them benefit from the reused materials, for example, in the production process. So it's only a question of time until the cost calculation of the suppliers needs to mirror the savings by reused material. Do you agree on that, Ed?
That's where one of the fundamental changes is coming about. As we said earlier, there was a closed ecosystem. If you were supplying the motor industry, that was it. You were supplying the motor industry. Now you've got newcomers coming in. So one of the theories, or one of the about the chip shortage, is that the motor industry decided to play Big Brother and tell the chip guys how much they wanted to pay, and the chip guys have got so much demand. Sorry, just a cough. That they actually don't need. Sorry. Cough. They don't need the motor industry. Whereas if you were a seat supplier and you were supplying the motor industry, that was it. That's your only customer or sector. If you're making chips or if you're making plastics, the motor industry is, it's nice to have if it's profitable. You don't actually need them in your life, and that's the OEM. They're not quite sure how to cope with that yet. I'm being over dramatic, but where they don't have, they don't hold on people anymore.
Okay. My question would then go to the materials. Let's dive a little bit deeper into the materials which are mainly used in today's cars, and have a discussion about how the future materials might develop and which ones they might substitute. Let's go, for example, to the major used material in a car, which is polypropylene. Frank, I guess you can confirm that we have the majority of materials in the interior of the car made of polypropylene. Then we have polyethylene in the engine compartment and the fuel system and so on. Then we have polyurethane with seatings and linings. So where do you see most potential for new materials, like bio-based materials, like recycled materials? Where can they go into, and which ones will they substitute?
That's a good question. So probably without a simple answer. So from the say from the demanding or changes in demanding, all the materials are so all the materials have to be considered. So, for example, if you look close to the electrical power strain, so you have polyamide or PBT, so which today are more or less in the under the hood, for example, besides other applications, but you have completely different requirements. So when you look, for example, on electrical properties, so you get higher voltages in future, and so that has to be considered. And from this point of view, or integration of sensor materials, so where you need probably rather absorbent, rather transmitting materials, for example. So this will be a change on this side, I would say, rather on the engineering plastics. And as you said, so in terms of reuse or recycle, probably the bio-based materials and also post-consumer recyclates. So if I had to guess, it's today a little easier so to go on the PP and PO materials, but there are also some possibilities, for example, to make PA6 from renewable resources. Maybe in the longer future, also biopolymers itself can play a role in the, or larger role in the interior, for example. Yeah. But I would say it depends on the application. It's difficult to say with a general rule.
Yeah, maybe we can get some insights from Dhanendra, because maybe you can release what your scientists are working in your secret laboratories. Because come on, we are amongst ourselves, so you can freely talk. And what technologies are you working on, and where we will see new materials in the close future?
Absolutely. I will be glad to talk about it. And I'd like to build on how Frank was mentioning about the flame retardancy. You know, electric vehicles are different. It's changed from legacy mechanical systems to electrical systems. And as soon as you put a battery in a car, several things are changing with respect to the performance requirement. And that's how the requirements for materials are changing. So the one thing we have been really working on is flame retardant thermoplastic materials. And there were recent innovation is flame retardant polypropylene resins. Nobody can believe that a polypropylene can be made flame retardant. So we have introduced a brand new resin family from a polypropylene resin family, which has a glass and FR additives. And these materials, when they come in contact with the fire, they start forming the char. And that char over a time becomes an intumescent layer. And that becomes a protective shield. So this material is already commercialized. We have globally the first use of thermoplastic in a PHEV battery cover in China with OEM Honda. And this old new innovation recently was recognized by the Edison Gold Award. It's a very prestigious innovation awards which recognize excellence in the product innovations and technologies. So you see the change. Steel was the material for the cover. It's globally the first time the plastic is being used from the polypropylene family, which will help address the cost dimensions that we have been earlier talking about. Everyone is looking for a lower cost solution, lower environmental impact. At the same time, a reduced lead time. How can we bring these solutions ready for the customer in a fast way, so that they can put these solutions, validated solutions, in the next car or in the next battery. So that's one aspect. From the battery side, the flame retardant material, then high voltage systems demand for high CTI requirement. Orange color, customers are asking for orange color on the high voltage components. That's where we have been focusing on. So this is all on the battery and electrical side. And if you look at architecture of the vehicle, that is also changing. Now, engine goes away, then there is no system which is making noise or lesser noise. There's a system which is less heat on a compartment side. So the dash panel of a vehicle, which separates the engine side and the compartment side, there are opportunities coming up for use of plastics. Now that there is no engine, so the whole front area, the front trunk, we call it front, that area where customers can put the luggage in a car, the plastic is being used. Plus a whole grill in a car. Now, earlier engines used to be the differentiator. Everyone was so much proud of, hey, I have the best engine technology. Now the differentiation is coming from the styling as well as efficiency. So
there's another trend in the automotive industry, which actually is individualization of the cars. So instead of having mass-produced cars, people are looking for their own single and individual cars. So there is one technology coming into play, which we see more and more, maybe in the future even in serial production, which is additive manufacturing. So Ed, what possibilities do you see, and how will additive manufacturing or 3D printing change the automotive industry?
Well, yeah, again, that's very exciting. When they get their speed up, yes, you can have a mini, you can have an outside mirror, you can have personalized or whatever, and then they're also printing now metals for brake components and stuff like that. So it's a more complicated, complex part that you can now print as a 3D print rather than trying to cast it or machine it. So yes, I'm again, I kind of see it as a technology that's going to maybe completely overturn things. But what's quite exciting about the technology as well is when you get to spare parts, it's going to reduce the cost of spare parts, it's going to reduce inventories. If I'm a garage or a dealer's service center or something like that, I can now print the parts that are needed, and they're kept on a stick, or they're kept on a memory stick, or they're kept in a memory somewhere. I don't need a huge warehouse full of components anymore, and the inventory costs of that, and the logistics costs. So yes, the more of that we can get, so there might be the way it seems to be going at the moment is that in the startup you use additive manufacturing, and once you get to scale, it's still cheaper to use injection or whatever. And then as they're scaling down again, as it's running out, they go back to additive. And then for parts availability is additive.
You know what, gentlemen? This is my lucky day today, because we are talking about two of my favorite topics of all times, which number one is automotive industry, number two is plastics industry. So this is truly my lucky day today. So thanks for joining. And ladies and gentlemen, dear viewers, if you want to participate in our discussion, please do so. You can type in your questions or remarks in our chat box, and I will read it here. I have my tablet computer here. I can read when you're typing in these things, and I will pass them on to my guests, and we'll try to reply to that as good as we can. The next topic is one which is closely connected to the plastics industry, which is the cost efficiency. When we're looking back to the early days of plastics in the car, let's say in the 60s or 70s of last century, plastic material was mainly used to reduce cost. It was known in the market as a cheap material. Nowadays, this has drastically changed, because there are high-performance plastics, there are luxury touch materials in the interior of the car. Well, we can say mainly the whole interior of the car is made of plastics. So it's not a cheap material anymore. It has come to something grown up, I would call. Was the industry, Dhanendra, was the industry able to convert this change of image into a gain in profits?
So, sorry, I would like to understand a little more the question, Guido. So you're talking about as from a plastic industry perspective, or? from the
Yes, I would like to know
government.
if the plastics industry was able, if the plastic industry or the suppliers have been able to use the improved image of plastics over the years to make more money out of that.
So, always industry is so much experience with steel and aluminum, and when it comes to the plastic, the first thing comes up, okay, the plastic will not work for the destruction performance, or plastic will not work for the fire performance or the impact performance. But it is changing because customers are really looking for more optimized solutions for better performance at a more competitive price. Plus, when you add functionalities like flame retardancy or the EMI shielding or the CTI, high electrical properties, you bring more value to your customers. And that's how these materials are being more and more being asked by the battery suppliers as well as the car manufacturer, because at the end, it brings value for them. At the same time, as we add some functionalities in the plastic, those becomes little differentiated materials, and so it's good for the plastic industry as well.
There are some materials in the car which have been improved over the years, which have such a nice touch and view that customers even don't know that it's plastics. Which potential do you see in, for example, interior parts to increase the value of the car by means of plastic materials?
Well, he was talking about it earlier, the personalization. I mean, already Volkswagen here in South Africa, when they're running at full tilt, they're doing a car, I think, every 1 minute, 15 seconds, and each car is actually individual. They've got the systems in place to actually make each car to order. So once you get your plastics, and maybe we're talking about the additive manufacturing, you can actually start making the inside of the car different, or the inside of the car more exciting. Because what's happening with electrification is that vehicles are becoming commoditized. There are people going to make motors, and you're going to decide whether you put the motor in the middle or you put it on the hubs or whatever, but you're all going to buy the same motor. You're all going to buy the same alternators or generators or whatever things going to be called at that stage. So it's the design of the car that's going to differentiate it, and then we start getting autonomous. They're talking about lounges. So it's got to be like your lounge at home, because you're going to be sitting in the car doing your work, or you're going to be sitting in the car watching TV or whatever. So it's got to have that feel. So yes, there's a huge possibility. And then obviously on the safety side, if they can make the plastics safer than a metal, it's not going to tear, it's not going to take your head off or something like that. In case of an accident, yes, there's huge potential. I mean, I'm still sort of stuck, because as you can see, I'm of the generation where you say plastic in the car, and I'm going, ooh. But it has changed. And yes, you're talking earlier about overcoming those kinds of feelings and the reputation of plastic. So the industry needs to do a whole lot more to say, you think you're sitting on leather, but you're actually sitting on plastic.
The title of today's show is Plastics in Motion, How Polymers Changed the Automotive Industry. But the question maybe should be, is really the plastic industry changing the automotive industry, or is it vice versa? Does the automotive industry change the plastics industry? Frank, what's your opinion? Is our title completely wrong?
No, I wouldn't say so. So it's probably in both ways. So, for example, if you have a good material, so a multifunctional material, for example, so you can actually deduct potential application in the automotive industry and vice versa. So you probably need, so for developing new materials, and this includes materials for automotives as well. So you need to know where you need to go to. So you need to target, and so I think it's probably so both industries need to learn from each other, and so in this situation, so the best fit of polymer use might come up. So that's my opinion on this.
Then, Enda, I would like to place the next question to you because I'm curious about today's everyday life between suppliers and OEMs. I would be curious to know who are the drivers of new technology, like who's doing more research and development on new plastic materials? Is it the OEM or is it the supplier? Who is in the lead of that?
I think it's both. Car manufacturers are demanding for more sustainable materials from the plastic suppliers, as well as the performance requirements are changing. That demands for really bold new materials. So the requirements and what to be developed comes from the car manufacturer side, and more material development research, material development work happens from a material supplier side. Again, this is my view. But as Frank was mentioning, it's a collective thinking. Together we need to think differently about the solutions which are being used today, about the solutions for the future, and help each other, which can bring value to the end customers.
Okay, got you. Frank, can you confirm that? Who is ringing on your door more? Is it the OEM asking for new solutions or the supplier?
So this is also different. It really depends on the question. So if it goes to new materials, so I would rather see new materials earlier in the product chain. So that means more the chemical or plastics industry, maybe the suppliers ask for materials, and so the OEMs bring the requirements. But they wouldn't go for complete new material unless it is on a, let's say, TRL, which can be actually used today or maybe near tomorrow. And I think that's a question of technology readiness level, and mainly on, okay, if we go on the material level, then more the plastic industry knocks at our door in this case.
Okay, the next question, and we are coming closer to the end of our little show, but my next question, I'm very curious about, Ed, this might be for you. These topics that we've discussed about earlier on, like recyclability, like circular economy, like new materials, like bio-based materials. Are these technologies asked for by the final customer? Will this trend come from the final customer, or is it something that the OEMs, the brand owners, will have to invent first and then offer to the market and see how they react? Where do you see the pull action?
Well, again, the input we're getting is it's demand driven. The OEMs are being, not that they aren't committed to the economy, to environment and all this, but they're actually being forced into it. They're being forced into it by legislation, and they're being forced into it by consumer opinion. So they're turning it into a positive, saying we've got green cars and we've got wonderful cars, we can now recycle and all this. But definitely they're being forced out of their comfort zone. You've got a company with engineers who spent their life doing internal combustion engines. Now suddenly they've got to think differently about the car. I mean, first of all, first electric cars, you just took the engine out and put in an few electric things. Now, as I was saying earlier, Andrew was saying, you can rethink the car. You actually start again. You need 4 wheels probably, and that's about it. And you need to steer somehow, but now you can steer by wire. So everything you learned, isn't there anymore. I mean, I can use a kind of a parallel with myself. When I started doing television, we still had just moved from film, and you couldn't film what this light that you're filming me in now. You couldn't use without lights. You used to carry around 50 kilos of lights. And now the cameras can do whatever they like. You can shoot wherever you like. So when I try and write a script nowadays, I still look at the light problem, or I look at the sound problem, I look at that. The kids don't have a problem with that because the cameras could always do that in their lives. So the new generation of engineers are going to come out thinking, yes, it's got to be a connected car. Yes, it's got to be able to drive sideways because I don't feel like parallel parking or whatever. But it's a whole new thinking. It's pretty, very exciting.
Okay, so if we look at the perspectives, the plans of various governments worldwide, we heard some figures that they will try to substitute the internal combustion engine driven cars into electrical driven cars by 2030, 2035, 2040, depending on the country and the area. So let's say 2040. To be the latest. Let's say, Dhanendra, what would be your estimate? What will be the percentage of plastic components in a car in 2040, when we already have a completely electrified drivetrain and stuff like that? So today we have around about 15% of the car plastics material, weight-wise. What will it be in 2040?
It's a grade of 15% by weight and about 50% by volume. Correct. Those are the non-structural parts, and now as more and more structural components in a vehicle will be changing towards the plastic, because that's where the value comes up. The actual weight are in the structural component. The performance requirements are on the structural component as well as the battery itself. So we have been looking tremendous growth for use of plastic, as well as the aluminum. So I think aluminum and plastics both will be growing with a very fast rate. Our estimates are about 15 to 20% CAGR. That's a growth rate we are expecting as the electric vehicles go faster, comes faster. Use of plastic will be it will be increasing with a faster rate.
Okay, sounds like a good business case. Frank, what's your opinion? In terms of R&D, do you agree? Will this be roughly the percentage in 2040?
Yeah, so I would actually expect from the percentage, I would say could be a good guess. Yes, from the, I think it will be also not just one technology, so it would not be just electrical driving. By batteries that we know today, for example. So, and from this side, so probably fuel cell vehicles would also play a role. So maybe more for the truck and bus side. But anyway, they could play a larger role. And if you look at the system weights, so that might influence also the I would say weight fraction of plastics. So even so, it may not be just the mass of plastic. So I think if you look at the mass of the plastic, yes, I would agree, 50% is reasonable. And so it also will, in my personal opinion, so innovations in terms of functional plastics, smart plastics. So this will develop, and materials integration on really a chemical level. And so this might be an aspect that the value, the added value plays a role just beside the percentage of how much of the material, of plastic materials is in the car.
Ed, you are the last in the row. If you ask your crystal ball, what does it tell?
No, I just what I hear you saying here is quite interesting. It's if you think about it, the plastics are shooting themselves in the foot in a way because they're lighter than steel, so they're almost never going to catch up because or than other materials, because they're just making the car lighter anyway. So as a percentage of weight, they're on a hiding to nothing. what Ananda was saying was in terms of value, and that's probably where the industry is more exciting. And you asked earlier, they're going to make more money. Yes, they probably will make more money out of it. But the percentage of plastics might not even change that much in terms of weight, because the whole damn car consists of one huge heavy battery. So ton of battery, it doesn't matter what everything else weighs, you still got a ton of battery. So unless we get the newer technologies and lighter batteries, the plastics, they're going to have more value, and they're going to do more exciting things. But don't look at weight. It's almost not important, because they'll make the car lighter.
All right, ladies and gentlemen, we have come to the end of our today's K-Talk. It's been a real pleasure having you on the show. Thanks so much for participating, and all the best to you. Dear viewers, thank you for joining today. If you want to watch our K-Talk again or share it with your friends and colleagues, just have a look at our landing page, where we will shortly place the video on demand. You will find all our previous shows there as well. If you want, we will meet again next month in our 7th edition on July 21. We will discuss about plastic trends in architecture, building and construction, so don't miss it. Thanks again for watching, stay healthy, and bye-bye.